Great. Thank you for reminding me, Richard. All right. So I hope everybody is able to clearly hear me. And so let's jump in. Before we start, do you have any questions related to NoSQL or any of the topics which we have discussed so far? No questions? All right. So till last time we discussed something about column oriented database, and then we talked about column family oriented database. And then we were about to start on HBase. Did we start on HBase? I think not yet. All right, let's start with HBase. So I hope everybody is clear about CAP theorem and why did we need NoSQL in place. So first, the motivation part. Why do we need NoSQL in first place? I hope everybody is clear about that. So the simple answer is when you require humongous traffic, then you go for NoSQLs. Okay, humongous read and write both. Okay, and whenever you are operating record based, you cannot really use HDFS. Therefore, you generally go for these kind of NoSQL databases, because when you have to manipulate records, you can always think of record as if it's a single line in a big text file. If you have to edit a single line all the time, then you require a better system. All right. So there are many systems, and one of those is HBase. So we'll talk about HBase in detail today. All right. I hope everybody is clear about what is column family oriented database, what is row column oriented, what is row oriented, and the kinds of NoSQL databases, and, and so on. All right. Good. Good. All right. So as we discussed last time, out of CAP, a database could only promise at max 2. And HBase chooses to C and P. C means it is consistent and P is for partition tolerant, which means if which means HBase will be running on multiple machines. And in case some of these machines go down, still HBase will not be impacted. Okay, the the more machines it can tolerate, we call it the more partition tolerant. The less number of machines a particular software can tolerate, we call it less partition tolerant. All right, so it is consistent, and which impacts its availability. So the moment if some database tries to be consistent, what happens is that suddenly it becomes um, less available. Reason being, if you have to be consistent, if certain database has to be consistent, it has to go through a single writer, as in when the user comes in, it should talk to a single window, a single system. Only then your database will remain consistent. Imagine multiple people trying to write modifying directly. Okay, so similar to HDFS, in case of HDFS also, the read write system, it is consistent and partition tolerant. Okay, HDFS is C and P because it has a single entry point called name node. Okay, so whether reader or writer, everybody goes to the everybody goes to the name node first and ask if this particular file exists or not. So that is about HDFS. So similar to HDFS, HBase is also CNP, consistent and partition tolerant. All right, but not humongously available. Okay, so to favor the consistency, they had to sacrifice the hues availability in case of HBase. So it is a column family oriented database, meaning we define columns, we basically define column families in the database instead of defining columns. Okay, and inside the column family we can add as many columns as we want at later point of time, not while defining the tables. Then, and also all the columns inside a column family stay together, are stored together. So HBase was designed based on a paper by Google called Google Big Table. Google Big Table was designed for storing the internet's data, and it was basically designed to store millions of columns and billions of rows kind of storage. And so this was the third component to be designed after Google after MapReduce, and MapReduce was designed after the HDFS. Okay, so these were the three papers by Google, and based on that it was designed. Third was, it is great for hundreds of millions or billions of rows. If you are talking about up to a million rows, then you will be more than happy with MySQL or Postgres or any other database for that matter. Okay, so if you want to go beyond, go into tens of billions or hundreds of billions of rows, then we talk about, then only we talk about HBase. Okay, I mean, as per HBase, it's great only after you have hundreds of millions of rows. Okay, not only tens of billions. Up to that, they say that MySQL and Postgres performs better. It's strongly consistent. Okay. Also, there is a concept called reason servers. Just like data node, HBase has reason servers. Okay, so in case of HDFS, you had a big file sliced into sliced into blocks. Here you will have a huge table sliced into regions, and these regions will be stored on reason servers. All right, so, and this process of dividing a big table into regions is called sharding, means cutting a big table and spreading it across multiple region servers. So this sharding or slicing happens automatically. Okay, similarly, in case one region server fails down, there is another region server in the backend. Okay, because reasons are at the end of day stored as SDFS file, and HDFS file has got replication and which can be recovered. Okay, so the failover is automatic and smooth. All right, and HBase runs strongly on HDFS. That is the downside of HBase. It cannot run on any other storage. Okay, there is a tight coupling between HBase and HDFS. And if you have to do a massively parallel computing on HBase table, I mean as Hughes table on Hughes table, you can use MapReduce inside HBase itself. It provides API in the form of Thrift and Java both. So any system which uses Thrift suddenly exposes APIs in almost every programming language. So API wise, HBase is fairly stable to an extent that Google Compute Engine has started supporting the same API on their Google storage. Also, there is a concept called co-processors, which is similar to the database triggers. And under the hood, similar to indexing, it provides something called Bloom filters. So Sanjay's question is at this point, good question. Let me just create our notes file and start with it. All right. So, and what was the date today? 3rd October. And the session today is, I think, 9. Right? Session 9 of 29th August, 8:30. All right, here we go. All right, so the question from Sanjay is sharding vertical or horizontal or both? If there is both, we will see it further. But in terms of the way sharding actually works is it only takes into consideration the rows. Okay, so it's a row based partitioning. Hello Lux, welcome. Yeah. All right. So today we are talking about the HBase. All right. So we will talk about. All right. So sharding is based on horizontal, as in. So if you have these many rows, so or how should I say, a shard is identified by starting and number of starting ID, starting row ID, and number of rows. Now you are clear? It is not identified by the column names. Now there is a question from Lloyd. Do we define the number of region servers or it is automatically picked up by HBase? Number of we define number of region servers. Okay. Also, we can keep on adding HBase region servers as and when we want. Okay. Now that was my answer. So do we define the number of region servers? Okay. So it's not that elastic. Now there's a question from Sandeep Mane. What is thrift? All right. Good. Good. All right. I'll try to be as brief as possible. So thrift is a service oriented architecture. Okay. It's a, let's say, I will be more clear. So let's say you are building a good service, great service of phone book. Okay. Let's say you are building a phone book service whereby users can look up number and add number. Okay. Now, how will you expose your phone book service? You want it to be global. You want the whole world to be able to call your phone book. Okay. One is that you give a REST interface, but REST interface will be slower. Okay. Also, in case of REST interface, since you have to parse the data again and again, there is an overhead. Therefore, it is little slower and more effort. Okay. Now, the other way is to provide thrift interface. Okay, so you will code on your server in thrift interface language, intermediate language. Now, this thrift file will get converted into all, okay, converted into all possible, converted into client library, all possible languages. So you don't have to create all kinds of client libraries. You just implement this intermediate language, and rest of the work is done by thrift for you. Okay, so when somebody imports, let's say somebody is working in C sharp, they can import your C sharp DLL and then start calling your functions directly rather than having to deal with calling a REST interface and waiting for it and then parsing the data, converting it into numbers. So all of that headache is hidden from you and is taken care of by thrift. Okay, somebody is working COBOL, somebody is working on Java, somebody is working on Perl, somebody is working on Python. You will have all clients with zero effort. You will not have to put any efforts, and therefore you will find in the open source world. So thrift is a library given by Twitter, and it's really good. It's really fast, and it's really good way to build the services. Next is that if you have to build any kind of service, you will go for thrift, and that is why Hive, HBase, and other systems go for thrift. Is that enough, or should I go into more details? So look it up, and thrift is really good way to implement a service. So all you will have to do is implement, create your phone book, which has an interface in thrift, and the client will be generated by thrift generator, and you don't have to do anything. Great, great. So this is good enough. All right, getting back. So this is how it looks like on the prima face. On the surface, this is how the architecture diagram of HBase would look like. So the user interacts to the API, and here at this point, you we will be talking about a console, the console. Okay, so console also calls API. Okay, and why is it not visible enough? Okay, so your console or Java program or any other language, they will all interact with this API. All right. All right. So here, basically, console or any Java program or any other language, they will all interact with APIs. And then this API will talk to the master and reason. This is the heart of HBase. Okay. There will be one server called HBase master. and there will be lots of region servers, and inside each region server it will have a in-memory data structure called h file and something called memstore and write ahead log. We will talk about these things later. And the region servers will store the data into hdfs. Okay, and these the whole communication between master and all the region servers will be happening through zookeeper. Okay, so here this is a very block diagram, and this is the action what's happening. So the user goes to the master and tells that, hey, I want to create a table or insert 20 records. And master tells the user that you can insert it into this particular region servers. And region servers, when you insert the data, they create files for that data in HDFS. All right. We will see how does it look like on the HDFS file system when you create data in HBase. Also, your question would be that what is it that Zookeeper is doing at this point? Why are we talking about this particular cloud? Okay, so whenever a discovery comes into play, there is a zookeeper. It's like a traffic light where master as well as all the region servers are keeping an eye on, and they are communicating to each other. Or you can think of zookeeper cluster as a common shared whiteboard, and where all of these people are updating their status. Okay, all of these master and region servers are updating their status. So Sarna's question is there any relationship between name node and HBase master? No. Okay. So HBase master or region server is just a client for name node. Okay. HBase is just a client to HDFS. All right. They don't have to run on the same machine. They don't have to run on. Uh, I mean, HBase depends on HDFS, but that doesn't mean then the name node needs HBase in any way. But they look similar to each other. Okay. The purpose of both is same. Purpose is of both name node and master node to act like an intermediary between the client and the actual data where it's stored. So both act like a router. All right, there's a question from Lloyd. HBase can reside along name node, any best practice. So this should be avoided. Avoid HBase and name node on the same machine. As opposed to the common sense, you should avoid that. Reason being, both require good amount of RAM. Okay, and when we say HBase, HBase master he was talking about, and yeah. S- Good question. Next is from Sanjay. Region servers can be local to a data center and geographically, yeah. So they have to be geographically dispersed. If you put all of them in a same data center, chances of losing data is really high. So the distribution has to be similar to data nodes. Okay, so as a practice, you just generally keep on a machine on a general node, general general node, you keep one instance of reason server and one instance of data node and one instance of your, what do you call, application master, or you can say node manager. All right, node manager, or in earlier speak we could say task tracker. All right, so one component from yarn, one component from the reason, the HBase, and one component for from HDFS. These are the three things you will keep on a general node. Okay, and you will keep these together, and the reason is, the main reason is that node manager needs to be near the data. Similarly, region servers need to be near the data, and all of that is very much required when we are doing the big data computation. Okay, make sense now? So they generally need to be together on a single node. Good, very good set of questions. All right, now we will go into the description of each and every topic which we have talked about so far. And if you have any questions at any point of time, feel free to ask. Okay, so we'll go into, let's say, what exactly do we mean by reasons. So every table you create inside HBase is automatically partitioned horizontally into regions. Meaning horizontally as in, if you have a big table, like, let me just draw something quickly. When I say, okay, so let's say, we can say, can we, all right, let's say we have this bigger table having these many. This is one row, this is another row, this is another row, and this is another row, and this is another row. Okay, so there are chances that uh, so all right, so let's say there is this big table which we are trying to store on HBase. It has got many rows. So when we say it will get splitted, it will get basically sliced. So as the number of rows are increasing in this table, as more and more data will be pushing into this table, more and more rows we are creating, it will split into half. Okay, it will split into half such that the data from here to here goes into one region server, and here to here goes into, so it will split exactly into half. Okay, this goes to region server 1, region server 1, and this goes to region server 2. All right, so just like how should I say, it gets horizontally cut, and total number of records in these two region servers will become equal. All right, so can I in any way cut it? Is it, can we cut it? All right, so if we take, let's say we have this much slice, and okay, this much slice, and as and when we will add more and more rows to it, more and more rows to it, we are adding more and more rows to it, it's becoming bigger, and after a point of time when it reaches this size, it will again split. It will again split, and this will move to a new region server, say region server 3. Okay, so that's what will keep on happening all the time on all the region servers. So it will keep on creating more and more regions, and there are chances, if you're if you have less number of region servers than your threshold, there will be more regions on one region server. Okay, it's not required that one region should be on one region server can have only one region. Multiple regions could be on one region server. And as in when you add more machines, these region servers distribute in order to equalize the load. In order to make the load on all region servers equal, these regions keep on moving across onto your new machines. If you remove one of the region servers, then they will redistribute in order to fit into existing one. All right. Now, next question is I'll answer your question after we discuss all of this. So, so tables are automatically partitioned into horizontally into regions. Each region comprises a subset of table rows, and each region is each region is denoted by the table it belongs to, its first row which is inclusive and the last row which is exclusive. So when we define a reason, when we define a reason, not reason, when we define a reason, it means a set of rows. It does not mean that it's a list of row IDs, because row IDs in HBase are always sorted. Row IDs in case of HBase are always sorted. Therefore, we can define region server by each region by first row and last row. If we just mark that this is our beginning of the region, this is the end of the region, and that should be good enough to define the section, that's good enough to define the region. The key point here is the data is sorted by row ID. Okay, by default row ID is the primary key. There is no alternative to it. We cannot deny that. Okay, so initially a table comprises of a single region. So initially when you create a table, there will be only one region, and we will keep on adding the data. As the size keeps on growing beyond the threshold, it will split into a different set of rows. It will split exactly into two halves. Until the first split, the whole loading will be against a single machine. As the table grows, the number of regions keep on growing. Okay, and here there is one more point I want to make, is sometimes there is hotspotting. Okay, the hotspotting is, let's say we created these regions. Let's say there are two, this particular machine is containing these two regions, region server 1 and region server 3, and for some reason, for some uh, I mean for whatever situation it is, for some circumstances, most of your users need this data. Okay, so these regions are on only one region servers, and therefore these region servers will get hit badly. While other region servers are free, one region server might get busy if the data it carries is really very important. Okay, in these circumstances you can force HBase to split the record. You can split the regions manually as well. Okay, the moment you notice that there is a hotspotting happening, okay, you do a couple of things. First, you change your strategy to create the unique row IDs. Okay, maybe it's because your row IDs are not well spread. Second, it could be that it is just circumstantial, so you can split the region into multiple regions forcefully, and thus you will distribute the load onto multiple machines. Okay, so there are two things you can do. If you realize that one of the both the region servers are getting equal amount, both the regions in on a region servers are getting equal amount of load, So you could do, first move these two regions onto two different machines. Okay, that way you have quickly halved the load. And still, if you see that still that all the load is still coming to these two machines or this machine, you split that region into two. So this is how you deal with the hotspotting. Okay, so there are two. One is region hotspotting, other is region server hotspotting. Region server hotspotting means it so happened that all the regions that exist on this machine are under heavy demand, while all other regions on other machines are not in heavy demand. So you distribute these regions onto multiple machines. That is first step. If you notice that there is one particular region that is being hit most, as in most of the user want that particular data, you can divide that, you can forcefully slice the region into further smaller regions and distribute it. And that way your ability to handle the load will improve, because the way region servers reason, it does the automatic scaling, but only for writing, not for reading. It does not detect that lots of people are trying to read the data, and therefore we should automatically replicate or split it. It only does that for writing, meaning when you keep on adding data to one region and the region is becoming bigger and bigger, the region will split into two and will distribute the storage load. Okay, I hope I made it clear. All right. Also, as the table grows, the number of regions will of course keep on growing. All right, now coming back to your question, so Ravikant's question is, does Zookeeper acts as a load balancer? All right, does does Zookeeper acts as a load balancer? All right, so let me try to answer. So a load balancer, for those who are not aware about what is a load balancer, a load balancer distributes the load which is coming from many clients. So on one end of the wire you have, say, thousands of servers, and on another end of the wire is millions of users. Okay, millions of users. Now in between is there you do all kinds of load balancing. Also, load balancing is not only done through one machine. There are all kinds of load balancing techniques, okay, such as DNS load balancing, such as mm, I mean the IP based one, and then comes to the machine. So the load balancer also plays multiple kinds of role, as in, if a user came for the first time, it would try to stick it to the same server. Okay, so when basically for the first time when the user comes in, it will mark that this user is going to be accessing this particular machine. Next time the same user comes in, it will try to send it to the same machine. So those kind of stickiness it shows. Also, load balancer takes care of cookies and everything, right? So that's the objective of a load balancer. And similar, on the prima facie, this is how the load balance Zookeeper also looks like. Okay, Zookeeper also looks like this, but the objective is different. Okay, so most likely there will be a load balancer here. Okay, load balancer, and load balancer internally will be using will be using the, okay, I'm trying to make some cool art. Yeah, so a load balancer will be internally using Zookeeper. All right, so it won't be like a Zookeeper will not be the kind of a load balancer, but Zookeeper is needed for discovering the clients. Okay, discovering the clients. I mean, when we say client, it is sort of, how should I say, these are the clients of Zookeeper. So Zookeeper is on both hands. Everybody is a client to the Zookeeper. So master knows who are its region servers available at this point. Similarly, these users would know that there are these many machines available to us. They can talk to them directly. Okay. While on the other end, the these I mean, master knows what are the region servers. Similarly, region servers do not talk to master directly. Instead, they give their attendance to Zookeeper. Okay, so whenever master have to know how many region servers are alive, they just talks to the it just talks to Zookeeper, and Zookeeper tells, okay, last time these many people gave me the attendance, and these many people have not responded for last 5 minutes, so I'm assuming they are no longer available, and therefore only these many servers are available. So that information is given by Zookeeper to master. We will go into a detail, if your time permits, if we'll go into details of Zookeeper today or tomorrow. Okay, and that's quite much detailed than what we're talking about. All right, so this is how it works, and the only difference is these users do not know much about these machines. Okay, while in case of this, in case of Zookeeper intermediary, Zookeeper will just give them the IP address and give them the list of all the servers. Okay, you will get to know more when we talk about it tomorrow. So Savna's question is, how is the split size defined? Okay, in terms of megabytes. Okay, we will define it in terms of MBs. You can have a look at here. Okay, same question is there from Lux also. All right, so you can have a look at HBase and go to the config. All right, all right. So this, now you can see that. So this is the file size that dictates how big your region server could be. It's a maximum HStore file size. If any one of the column families HStore has grown to exceed this value, the hosting H region is split into two. Default is 1 gigabyte. We have changed it to something else. Is it 1 gigabyte still? 3 plus 3, this is 1 mega. 3 plus 3. Okay, mega. No, it's 10 gigabyte, 10 gigabytes as of now. All right. So this is how you can change it from Ambari, as well as same thing is available in HBase site. You can edit that file, and but that edit has to be done everywhere consistently. So that is why we recommend using Ambari for that. All right. Now there is a question from Sarvna. It's a follow-up question. What is recommended? Okay. So a good idea to have the reason is basically number of machines you have, and the default 1 gigabyte is good, provided that we will be talking about petabytes of data. in HBase. Therefore, having a 1 gigabyte uh, size is good enough. In case of petabyte data, uh, okay, there will be 1 million reasons. Okay, and thinking about that, 1 gigabyte is good. The default is good enough. All right. So Sanjay's question is, does the reason server shrinks in case the rows are deleted? No, but you can do the compaction by yourself. Okay, you can have a look here. There is something called compaction somewhere. Okay, you can compact the region server by running some tools, right? uh, on the region server bit, regions we can keep in region server is defined by the data node size. So the number of regions we can keep on region servers is generally a distributed. It tries to distribute the regions to multiple machines. Okay, it tries to distribute these on multiple machines. It is not. It has no. It doesn't function in terms of data node size. All right. Let me go back. So Anandita's question is, what is the maximum number of regions, or it just keep on adding regions as the size? There is no upper limit actually. Okay, it's governed by your HDFS size. If it can store more and more H file, then it'll keep on creating more and more regions. Okay, the only downside of having smaller regions is that it will overload HDFS very quickly. Second, if you have very small regions, then your master will also have consume more memory, because master will have to keep a record of all the regions and which region is having which row. That kind of data need to be maintained in the memory of main HBase master. Okay, so if you have smaller regions, both get hurt, name node as well as HBase master. If you have very big regions, then what will happen is, as more and more data is coming, then only single node will get busy, and that is something you can always that's where you generally decide on a safe region. Okay, and that 1 gigabyte is good enough region size. All right, so okay, I think talked about. All right, these two questions are similar. There is uh, no I mean constraints. Okay, generally it will try to keep all the region servers will try to keep equal number of regions. All right, there is a good question from Sandeep. In case of region hotspotting, how do we come to know which region server has maximum reads? Does it has something like Ambari? Yes, it does. We will go into that detail quickly. Okay, now there is another question from Lux. Question is, reasons we can keep in region server is defined by data node size. Okay, no. Okay, these are generally distributed equally. All right. Next question from Sandeep Mane is, how millions of columns are stored on data nodes? Do they also split like a reason? So when millions of columns are stored on data node in a format called H file, and that file gets stored in HDFS. Okay, if you have millions of columns, they will go uh, along with each reason. You will see it as we go forward. All right. So reasons do not have replication of its own. The replication is given by mainly by HDFS. Okay. Replication is provided by HDFS because at the end of day, each reason is being stored as a file and that file is replicated. Now there is a good question from Lux. He says that to me, region server look like a way to distribute the data across multiple server. Yes, which is similar to block size in HDFS. I am confused why HBase has a different approach when storing files in HDFS. So see, in case of HBase, you need to understand this part. So basically, your question is then your question is that I mean, why do we need HBase, right? That's your question. What difference are we talking about here? So I will give you the difference, okay? In HDFS, you have append only. I will just make a list here, and here is your HBase. Okay. So HDFS is append only, meaning as you append data, more and more blocks are created, right? But if you added a block, it is a disaster. Okay? If you added a line, if you added a line in HDFS, it is equivalent of equivalent of creating a new file. Okay? Now, in case of HBase, it is because we are splitting from between, right? So you can insert the rows. You can insert rows in any region, in any region server, in any region actually, meaning you can insert any row at any point of time, which means it doesn't, the new row would not come only to the end. Therefore, the row is going, and the fresh row which is coming from user is going to anywhere in the table, right? It could be in the top, it could be anywhere. Therefore, any of the part will keep on increasing. And therefore, as more and more distribution happens, okay, it will be far easier to edit the block, edit the sections rather than only appending. And therefore, there is a difference in the approach. Does it make sense to you now? All right. Now, there is a question from Lloyd. What is the best case for HBase? How are companies using for HBase, using HBase? So whenever you have to have a database, and what is the quality of a database? Database provides you very efficient CRUD. as in create, retrieve, update, and delete records, not the file. File is a big object. Okay, so if you have to edit the records, if you have to edit the data in the form of records, then you go for HBase. If you want to deal with appending files or creating files or deleting files, then you go with HBase. If you notice, if you notice that you are trying to edit a lot of HDFS file, you are all the time editing the file, that means there is something wrong in your design. You should not be having HDFS file in first place. You should be talking to a database. The moment you realize that, oh, your application is all the time writing the file, editing a file, then your design is wrong. You should go for database, not the file. And that's when you say that, okay, we'll go with HBase. Right? Make sense to you, Laksh and Lloyd? Now, next question from Lloyd is very good set of question. I mean, come very. This is probably the best batch I have. All right. And what happens if one reason server is down? What happens to the reasons on that server? Can these automatically be available on other regions? Yes. Okay. So if one region server is down, it knows that this file is being replicated on other nodes as well, right? The this particular section of the file is available on other nodes as well because of the replication in HDFS. So it would instruct other region server to start loading that particular those regions. Okay, the nearest one. Okay, so when one region goes down, all the files on that machine have gone down. So we it will find out who is the nearest neighbor, who else is having those files, which data nodes are having those files. And I mean, because each region is stored like a file, it will find out those region servers and delegate them that, hey, from now on you are also responsible for this row ID to this row ID, please load it from that file. Okay, and that's how it works. Good. So Lux, was I able to answer your question? All right, now, very good question, Vidya. Vidya's question is, if a new row is added to a region, then how is the row ID affected? All right. Here in the whole table, every row has to have a unique ID. Okay. You cannot have two rows sharing the same ID. Therefore, whenever you are generating a row ID, okay, based on the row ID, your record will get inserted. Okay, let's say I will go to the next slide, and then I think I'll be able to better answer your question. Going ahead with next slide. Yeah, imagine that this is the layout of the region servers. Okay, you have got three region servers: region server 1, 2, and 3, and these are the row IDs. Okay, in the logical view, these are the total number of row IDs, some starting with A, some starting with H, some starting with Q, some starting with Z. Okay, the way they are going to be divided is, could be one of the layout could be this. So region server 1 could have the keys from T to Z and keys from A to C. The second region server could have these two regions, the keys starting with I and M. Notice the square bracket and round bracket. From the set theory, if you remember, no, this is number line. So from the number line theory, if you remember, the square bracket means it includes this. while round bracket means it excludes this. Okay, now you might notice that that means there is no reason server right now for the records starting with Z. So that's a kind of a mistake in this diagram. All right. So it generally, yeah, you generally, it internally defines the range. Okay. And that's how it happens. It defines a arbitrary last point, end point, and it'll be like /0 instead of Z. Now you can have a clear look that this is how region servers get distributed. If this region server start becoming getting more and more insert records, it will split, and that region will go to either another machine, or will stay on this machine, or might go to this machine, and that will keep on happening all the time. If you add more machines here, some of the region servers will move to that fresh machine which you have added, and the load gets distributed accordingly. All right. So does it answer your question, Vidya? So you will have to create a unique row ID. Row ID is not generated by HBase. It is you who has to create this unique ID. And if you are coming from a background where you have never created a row ID, or you have created earlier, you must have realized that you have to go through sequence 1, 2, 3, and so on. And therefore, it might be a big process. But there are really good techniques such as appending appending a particular identifier with UUID. Okay, that's a really decent unique ID. Now, there's another question from Lux. The question is, first is, do we keep the block size to 128 MB or 256 MB even with no? So HDFS is running happily, okay? We do not disturb HDFS, or we do not create a fresh HDFS for HBase. We don't do that. But here, block size of HDFS will remain as such. If you mean by block size the region server size, then as I was telling you that the in Ambari you have this htstore file. This is what will dictate whether to split a region or to leave it as such. Okay, I am still trying to understand this part of question. All right. If okay. Next is, I'm confused about how failover region server contains the same set of HDFS blocks that can make up for the. So see, at the end of day, user inserts the data into region, and region is stored. Each region is stored as H file on HDFS. It's stored as a file on HDFS. I'll show you that. And if one region server is down, okay, so that region server is gone, but that does not mean the file is gone. And this information is with HBase master. So it can tell any other region server that, hey, this particular file, can you also start loading it? And it will find out, because file is not gone, the H file is not gone, it's there in the HDFS. Therefore, the other region server can start loading it. Did I make sense, Lux? Next question from Lloyd is, where is the metadata stored regarding regions such as range? So and follow up suggestion was, is it HBase master? Yes. Okay. This two is capped in the disk parallelly. Okay. Disk as in HDFS or simultaneously, you can say. All right. Now, there's a question from Vidya. Suppose Tj become bigger, then it will split into two Tj GS into dash V and V dash Z. Correct. Yes. Perfect. That's how it will happen. Okay. Is everybody clear about this? Suppose T to Z range, in this particular example, if this starts becoming bigger, then what would happen is let's say between Tj you have let's say TA, TAAA, TAB, and so on up to Z something. Okay, or you can say up to Y because Z is not included in this. Now, if you have YA, YAA, Y, something like this, and in case this becomes bigger, it will basically split maybe somewhere at V. This will become one region server, and this might become up to you, it'll become another region server. Good. All right. All right. I think that's a better example, better way to put it. All right. Great. So, Laksh, was I able to answer your question related to how HDFS blocks and HBase region servers differentiate? All right, because these are very genuine questions and these are important to be answered, right? Because other people might be having the same questions. All right, so everybody comfortable so far? So you keep on inserting the data or updating the data in a region server, and region server, uh, as and when that particular region on which the data is growing beyond the prescribed limit of 1 GB, it will split into two, and then then the in further inserts could be on the new regions that are being created, and these regions are created on region servers. So more and more uh, rows you insert, the more and more regions will be created. And as you add more region servers, this data will flow across the cluster. These region servers will get moved from one machine to another so that this whole mechanism, this whole system of uh, as and when we are adding more and more region servers, the regions will get distributed so that the load of creating records, updating records, or deleting records, or retrieving records get distributed amongst multiple regions. And each region is each region or part of the region is being stored in a file on HDFS. So every region is backed up with a replication factor of 3. So in case, let's say, this machine goes down, HBase master knows that where is this region server's file, and instruct the other, say, this region server to load this file as well, and this region servers to load this file as well. This is how it works. All right. All right. So the other important aspect we want to go into detail is the data model. As a developer or as a user of a database, we need to understand when to use a particular database and how to structure our data set. Okay? The way The way we have learned the modeling of data in relational database, the way we have learned is that every table is designated for each unique identity. Let's say there is a employee, and there are resources, and there are rooms. So we generally create rooms, employees, and uh, the third table, which will one table will be for employees, other table will be for rooms, other third table will be the association between employees and rooms. Let's say we are trying to assign the employees to the rooms. I mean, in the conference room. So let's say. So whenever we design our usual relational database stuff, we always kept these tables some way, right? Now, in case of HBase, that model is changed. Okay, the strategy, the psychology is very different. Most of the relational database was designed to improve the manageability of data, while HBase or any NoSQL is designed in order to handle the load, handle big data, handle scalability. Therefore, the design objectives are very different. Design objectives are different, as well as the so since the design objectives were different for these databases, therefore these tables or the databases offer different kind of semantics, different kind of behavior, and you need to solve that in general cases. So we will first go into an overview of data model, and then we will try to design one particular application, one particular architecture, and then we will go further, and there will be a design kind of a challenge for you as well. All right, there'll be a design kind of a challenge for all of you, and because the strategy of data modeling had changed in case of NoSQL or HBase. All right, all right. Let me answer one more question from Sanjay. Can we reorganize the mechanism of generating keys and redistributing the entire data across region? So it will be very difficult. Okay, let's say you want to change the IDs of all the data. Okay, if you want to change the IDs of all the data, it is equivalent of deleting the rows and adding fresh rows. Okay, because as you change the IDs, the distribution of the data will change. All right, I hope I have answered, Sanjay. Cool. So moving ahead, let's talk about the data model. We talked about the physical semantics, how the data moves, how the data is stored. I'll also show you physically where is the storage is, so that you get comfortable. All right, we'll create some table, and we will talk about it. But before that, let's understand the data model. Okay, because that is probably the most important part. All right, so the best definition of HBase is given by the paper on Google's big table. That's probably the most precise definition, because I'm not able to remove even a single word from the definition, or there is no addition of word required in this definition. Okay, let's talk about it, and we'll talk from the right to left. So it says that big table is a sorted map. Okay, let's start with exact right hand. So it says that big table from the data model perspective is a map. Okay, what is a map? It has got key, it has got key, or we will just, I'm just scribbling here. Okay, data model has got key and it has got value. All right. Now it says sorted map. Sorted map means the key and the value keys are sorted. Okay, so here key 2 uh, will be after this, and key 3 will be after this. All right, or if you have after KL, it will be after this. All right, and so that is one important aspect. Now let's go to the third keyword from the right hand side. It says multi-dimensional. It means that a value could have more data in it. Okay, there could be multiple values like this. Okay, and we can keep on adding these values as and when we want. Okay, and you could have more values like this. Okay, and there is no constraint that value number of values in first row and first second row are. We will go into that in a minute. Next is it is persistent, meaning if you make some modification to this data, if you make this modification to this particular value, it will get saved. And when you come back, when you try to retrieve this data again, when you come back, it will be there. These values will be there. They will not wash away, even if the machine goes down or something else happens. Next is distributed. Distributed means running on multiple computers, such that some keys on one machine, some keys on another, still it will act as if it's a singular system to the end user. And the last keyword is sparse. Sparse means this one has value for, and these are named columns. Okay, these are named columns. Let's say this is my name, this is name equals to this, age equals to this, address equals to this, and so on. Okay, so this might have name, or and this might have some other columns altogether. Okay, these are some C1, C2, and so on. Okay, so this is how the data is in this. Sparse means not all the rows will have same set of columns, and the way we have defined columns is by marking the values with a name, by marking a value with a name. Okay, so therefore it is sparse, as in some columns might have some same value, some column might, I mean some rows might have the same set of columns, but some rows might have completely different set of columns. HBase does not impose that kind of structure on the table. It sounds like a table, but it's a big hash map. All right, continuing with it. So the biggest unit of data in case of HBase is table, and keep in mind that since it is going to create a file, a folder inside HBase with the table name, so the table names should be safe strings. You cannot put binary data in the table name. Okay, it is important to note these points because you will just see that for some data you can put anything inside it. Like for example, column name or row ID can contain the binary data. There is no restriction on that. As a matter of fact, we used the column name to store videos in my previous instant at one of the organizations. Okay, we will see that quickly. Now, so a table is something which is the biggest entity, and it's basically something that is that contains almost all the data. A row in a table contain a row is something which is the horizontal one, and every row is as identified by a row unique key. Okay, it's called row key, which is unique across the table. No two rows can have any no two rows can have the same id. Row keys do not have a data type. Unlike our traditional relational database, there is no data type need to be defined on HBase. Even for row key. Row key is a binary data. And the way the sorting happens is a binary bitwise sorting. Okay? 0101 kind of a sorting. And basically anything you store inside HBase table is considered as a byte array. All right. Now, there is something called column family. Data within a row is grouped by column family. When we are defining table, we define how many column families are there and what are the names of these column families. Okay. So data within a row is grouped by column family. Okay. And the column family impacts the physical arrangement of data. You will see quickly that for one column family there is a single file. If they so for a row there will be different files storing the actual data, and column family is impacting that, making sure that all the data within a column family is closer to each other as compared to the data lying in two different column families. Okay, and column family need to be defined while you're describing your table. It cannot be easily modified. If you have to create more column family in your table, or you have to delete a column family or rename a column family, you will have to create the table again and then move the data programmatically. Every row in a table has same set of column family, but every row doesn't need to store data in all column families. All right. And column family, just like table, should have names which are safe for file system. Reason being, HDFS file will be created with the same name as column family. All right. Now there is a column qualifier or row qualifier or a column. Okay. Data within a column family is addressed by column qualifier. So in the table we keep on adding rows as well as we keep on adding columns inside the column family. Just like we keep adding rows in the table, in a similar fashion we can keep on adding columns as and when we want. All right. So if we are adding a new row and we want to add more and more columns, we are completely free to do so. And this column name is not something, the column name which we talk about here can contain the binary data, is a byte array. All right. And because we can add more and more column as and when we want, therefore we call these tables as very sparse. Now the last unit of data storage is cell. Cell is something which store the actual data. Okay, it's an intersection of which table, which column. So in a table, in a row, in a particular column, we have cell. All right. And the cell further have something called version. There are by default there are three versions of each cell, and and by default the way versions are created are based on the time. All right, the values that is stored in a cell in when you talk about Excel sheet, it actually behaves like an Excel sheet. We keep on adding row, we can keep on adding column as and when we want, and we don't have to worry about adding more and more columns the way we don't have to worry about adding more rows. And in the each cell we can create any data type, whether anything. And see, the only difference is that each cell is a version. Each cell has three versions, and that is something not there in Excel sheet. But I'm not sure programmatically it is there or not. So the version is basically the cell values we keep on versioning so that we can utilize that for multiple kind of things such as conflict resolution. If there are two applications which have accessed the same cell and have modified it, and we are trying to at later point of time we are trying to reconcile it, we can use this multiple versions information of a cell. If we do not specify the version number while adding a cell, a current time is used. If while reading, if we do not specify which version we want to access, then the latest version value is returned. The number of versions retained by HBase is configured for each column family. You can configure it for your own kind of utility. For each column family, when you can define that how many versions you want to have for each cell. The default is 3. An example is a better idea to describe what we have talked so far. Let's say we are trying to store the information about people. Okay, let's talk about this one. Here, let's say there is a table called people or persons or employees or customers. Okay, this customer has got a unique row key. You can see 001, 002, 3, 4, 5, 6, and so on. This customer has got two column families called personal information, personal address, and the office address. Okay, personal details and office details, you can think about it. And under this personal column family, you have name and the residence phone number. It's a personal details. So in personal details, there is a name of the person and there is a residential phone number or the mobile number. The official details is contains the office phone number and the address of office. Okay, similarly, if you have to add more columns such as home address, you can add it in the column family called personal. All right, also as people update their residential phone number, it will maintain multiple values of the past history. Similarly, if you are changing the name or anything, it will maintain the last three values. Okay, Lux is saying that these specs are similar to JBoss cache that we have used previously. Correct. Most of the cache, the way they are designed, is exactly in the same manner. And for that matter, memcached or there were actually JBoss cache was I have used JBoss cache once. It was an acquired company, if I understand correctly. All right. Anyway, so most of the cache systems behave the same way. Most of the cache systems are sorted map, which is sparse in nature. All right. Now, if we have to take this and convert it into the physical way, and this is probably a better way of looking at it. All right, if you have to look at the physical way, this is how we will look at it. So under a row, you have two column family called office and personal. Under this column family, you have two columns, address and phone number. Also note that this same name can also be here. Okay, you can have something of this sort here. Phone is here as well as here. So a column is identified by column family colon the phone number. Okay, because colon cannot come in a column family name. All right, and under each address there is a timestamp, timestamp 1, timestamp 2, and so on. Earlier his address was Market, and then he changed it to Market Street, and so on. So this is another way to looking at it. Now we are going to get into a real example. This is probably the most involving example, and we will talk about it after the break. Sanjay's question is, we can add, delete, change columns in a column family. That's correct. Yes. Yes. All right. Great. Let's take a break for 10 minutes and come back and then understand this particular example because of which the whole space was created or big table was created. All right. So break for 10 minutes, back by 10:04 p.m. 10:14 p.m. IST. All right, I'm back. Should we start now? All right. So let's continue the question where we left off before taking a break. So, question from Sanjay was, we can add change columns in a column family, but we earlier said that we cannot redefine a column family. Yes. So, so when we say we define or redefine a column family, it does not include how many columns or what columns does it have. Okay, defining a column family means just giving a name that, okay, my table, the way we'll define is I'll show you. We'll just define, say, create table, and it has got column family 1, column family 2. That's it. That's it. That's all we define as part of our column families. Okay, or we can say CF1. That's all we define. These two column family. If you want to define more, that's all. At the time of creation of the table, we do not do it at later point of time. All right. Once we have created a table, okay, then we can add data to it. It has to have some row ID, and it has to have basically it has to have the name of the column family and any column name. This is my column name and the actual value. Okay, so you can see that whenever we are adding the data, it is of this form. Okay, we will go into this API detail again, and that will give you a clarity on how does it look like. All right, now coming back to one question from Lux. So my question about region size is that 1 GB of storage for region need not to know. Okay, this 1 GB of H file, we call it H file because for each region server it creates a file, and this is stored in, say, 8 blocks if you have 128 uh, size of blocks, and that is further. Okay, these blocks are going to be in HDFS. All right, so it has nothing much to do with respect to the storage available on data node, or it has nothing much to do with memory or anything. All right, I hope, yeah. All right, now going back to Sanjay's question. Sanjay's question further to it is, we all have only row key for a table which is technical. There is no business key we define. No, we don't have something like a secondary index or secondary key at all. All right. So you can have row key which is based on some business criteria, or you can create another table where your criteria is the row key and the value is this particular row key here. So that those are the secondary, another table will be your secondary index. All right, great. Now a very important problem, the reason why we have HBase in first place. The reason we have HBase in first place is because a company called Google realized that the normal databases cannot handle the storage required for crawled corpus. Crawl corpus, as in when it downloads lot of data, it needs to keep on updating which website is linking to which one. Okay, so it stores all of this data continuously every day and keeps on updating the records, as well as it keeps on making note of which website is linking to which one. Okay, for that it uses this kind of model. All right, now here there will be lot of changes to what you have learned so far in your DBA school. Whatever you have learned about databases, you will notice lot of differences here. Okay, so we will start with a simple description. Let me think about how can I describe to you in a better fashion. All right, let's say there is a website called website called what do you call, yeah, let me just make sure, website called cnnsi.com. cnnsi.com. Okay, inside its data, inside its HTML, somewhere it is mentioning that a href equals to www.cnn.com. Okay, and with the name CNN. All right, then there is another website, or let first also create an website called www.cnn.com. It has got again HTML something inside it. All right, now there is another website called my.look.ca. a href equals to www.cnn.com, and the way we are referring is cnn.com. Okay, there's a lot of content as well. I'm skipping that content for the brevity. Okay, so imagine that there are these three websites. All right, okay, so you're building a search engine like Google, and your objective is to download the data from across the globe. All right, and when you are downloading this data, you also keep on making note of which website is linking to which one and how. For example, here there is a website called cnn.com. It has got some HTML content, and there is another website called cnnsi.com. The cnnsi.com is linking to cnn.com, and if you are aware about Google's PageRank algorithm, whenever one website links to another, it is essentially voting to another website. If you remember our discussion on PageRank problem in the first session, when we talked about the voting problem, basically the reason why Google came up with a great search engine was because of the PageRank algorithm. And the way they computed is, if the most important website link to your website becomes more important than all of the people who are voting your website. And in case your website votes to somebody, then that website is far more important to your website, and so on. So if there are lots and lots of people, if you are being voted by bogus websites, while my website is being voted by top websites which is voted by more people, then my website is more important than your website. Okay, so it's not only the quantity, it also means that the how much page rank it is. And the definition of page rank is recursively defined. Okay, if people vote for me, then I get some page rank. If I vote for somebody, they get a better value because of me. And that's how the page rank is defined. So, so in a sense, we need to know who is linking to who and how. In case you are linking to my blog with the name Big Data, and somebody else is linking to my website or linking to my blog with the name, say, Toys. Now, toys and big data are two different things and had nothing to do with each other. Therefore, it may be that my website is a spam. Okay, so for Google, other than number of page link that my website is getting, it also matters that how am I being referred by people. Okay, and therefore it also needs to track that information. So the problem statement is build a database where we can store all the website's data along with this information, who is linking to who and with what name. So this is the problem statement. You have to build a data storage to store all the corpus of the web, and also how is one website being referred by another. All right. So the truth is that when Hadoop guys started, they also wanted to build the search engine. They also led to the same point as what Google had done. Okay, so we have if we have to build this kind of storage, so on an average it's around 500 terabyte of plain text or 500 terabyte of the HTML and text data, which is there in on uh, there on the World Wide Web as of today, maybe more now. So now you can have okay. So now if we have to store such kind of data, what we could do is first we need a storage for the HTML. Second, we need to know who is referring to who. Ideally, if we are doing it using relational database, we will keep only one, we will keep one database in which we'll have entry of one table in which we have entry of the website name and the content, and then this there will be second table for links. But that's not the case when we talk about HBase. The way Google did it is by having a single table like this, which has two column family. One is called content, other is called anchor. Okay, so now let me just let's say create table, and it has got two column family called contents and anchor. Okay, now this is my table. Let's say table t equals to this. All right, now the moment it encountered this particular data, it inserted into t dot add row, and my row key is, let's say, the URL, say www.cnn.com. All right, and then we say under the contents with an empty column name. So empty column name is a valid column name. Keep that in mind, because column name could be binary, could be anything. Okay, so after here we could have the complete HTML data like this. All right, now crawler went ahead and downloaded another website called cnnsi.com, and for that it has again added another row called cnnsi.com with some content of HTML. Okay, like this. And there somewhere inside this is Okay, sounds good to you? Now, at this point, it also did one more thing. Okay, it said t dot put, t dot put, or you can just let's just, instead of saying row, let's say put. Okay, we are putting data for this particular row ID into this column with this data. Okay, so again, the moment it encountered the second website, what it's going to do is it's going to put another data into the same table, not same table. So it's going to go back to www.cnn.com, www.cnn.com. So in this row ID called www.cnn.com, it's going to put under anchor family, under anchor family, it's going to put the name, uh, the name called CNNSI. Now notice few things here. The data is going into column family. Okay, we are creating the column with the name of the website which it is being referred by. If there is another website that came along just like this one, we will create one more column in this row called cnn.com, and we will put the information here. Okay, like this, like this, and all right, this is what we are doing. No, I did not get what I'm saying. So, all right, let's go back. So when we encountered www.cnn.com, we added a row. Another time when we encountered cnnsi.com, we'll add a similar row for cnnsi.com. Along with that, we noticed after parsing the data of cnnsi.com, after going through the HTML, we noticed that this cnnsi.com is referring back to this website. Then we go back and put this particular column in our row. And column name we keep as the new domain name. So if there are a million websites linking to www.cnn.com, there will be a million number of columns. Okay, there will be million number of columns for www.cnn.com. All right. If it encountered Wikipedia, so there might be a million websites which are, or a billion website linking to Wikipedia. So there will be a billion number of columns. And every row will have different set of columns. Almost every row will have their own set of referrers, and therefore there will be own set of columns. So one row's column, the columns of one row has nothing much to do with the columns of the next row, and so on. Is this clear to everyone till here? So column name is being dynamic here. Column name is based on column name, not column values. Lux. Column values is another data point. So we are storing two things. One is column name and other is column value. Similarly, column name, column value. Which website is referring to www.cnn.com with what name? These are the two information which are being stored. And that's what I was telling you. Then in case of Cassandra, we were even storing a video in case of column name. And this is very important because the same story is with respect to Accumulo and same story is with respect to the Cassandra. That we utilize the column name. And to some extent, when we talk about MongoDB, the behavior is similar. We have no schema rigidity. If you are coming from database background, you will get shivers when people want to add more columns in the table. Okay, so whenever somebody thinks about adding more columns into table, it gives shivers to almost every DBA that now we'll have to plan and upgrade. We need to plan, migrate. Our table will become sparse and all that. So, but in case of HBase, it's completely okay. Just like the way we keep on adding rows to the table. Similarly, we keep on adding columns to the column family as and when we want. All right? Is everybody on the same page? Did it make sense? So it's a single table for all the information. It's, let's say we want to store the PDF data as well. So we'll create one column. We could do something like, we notice that there is another website called, let's say, Microsoft.com. So we'll create Microsoft.com. We'll adding one row, put this, and here we can add one more column called PDF. And here some binary data will be there instead of HTML, right? Some binary data will be there instead of HTML. So there is a question, let me address the question from Sanjay. So do we need an exclusive DBA for H-based type database? So basically the strategy for creating the scheme for HBase is little different. So generally the product developers take care of the design of the database. Okay, generally the developers, so far the developers have been taking care of the design of the database as well. All right, generally the administrator in case of HBase is responsible for making sure that there is no hotspotting and our HBase server is running fine. That too, they take care of the whole cluster rather than only HBase. You generally give them a note on the capacity planning. You generally give them a note, a rough estimate of the data you are trying to store and how many requests you will get on an average. Okay, I hope this is clear. So there are few information which we exploited here to store our crawl corpus. For first thing which we exploited was that more and more columns can be added. Second thing which we exploited is that uh, there could be, we could store the information in the column name. Now, one more important aspect here which we are not exploiting, that since our region servers have since the HBase table is generally stored as sorted by row ID, if we have to access the similar website together, we should not take too much time. Let's say we want to access all the subdomain of cnn.com. Okay, so we could store all that information together as well, right? And how can we do that? We can do that by making sure that all the domain names are sorted in such a way, the domain name is created such a way that when the usual sorting happens, they come together. So I'll give you a good example here. Let's take a case of, if so the way we have stored here is just for example sake. In reality they are storing this ID. Okay, they are storing this ID in the inverse way. Let's say you realize that there is a fault in this database. There is a fault in this database design because it's keeping the two rows two domains which belong to two subdomains which belong to the same domain, it's keeping them too far away. They are too far away. For example, if you sort this data, let's say www.knowbigdata.com and blog.knowbigdata.com, www.microsoft.com, microsoft.com, and google.com, and blog.google.com. Okay, let's say these are the domains, and then we have Hadoop 1.knowbigdata, bigdata.com, and apple.com. Okay, if you sort this data, and in Apple we have, say, www.apple.com. Okay, now if you notice here, what has happened is Apple and www.apple.com are far away. So this might be in one reason and this might be in another reason. Okay, so if we search for apple.com, we cannot descend down and iterate over it. Can we bring these websites together in some way? Can we bring, can we, can we define our row ID such that all the subdomains of one particular domain are together? Can we do that in some way? Because the only way we can control the placement of our rows in the table is by the way of defining IDs. Therefore, let's try to do something clever. We will inverse this. We will inverse this kind of structure. Okay? We will inverse this kind of structure in a way that I mean we will try to inverse it, and that way, let's say I'm using my regex techniques. I'm saying then dot and then dot plus, okay, in the beginning, and I'm saying $2 dot $1. Okay, this way I have swapped com with this. Okay, the another thing which we had to do was, okay, so $3 dot $2 dot $1. Okay, so this is good. www Apple blog Hadoop one W, but here we'll have to do it manually. So what have we done just now? What have we done just now? We have basically brought apple.com and www.apple.com together. Let me just sort it again. Now you can see that www.apple.com and apple.com has come together after sorting com.google and com.google.blog. Similarly, no big data, all three subdomains have come together, and so on. Okay, so the scheme which we have defined, the row ID, we are exploiting the fact that since our data is sorted by row ID, therefore, and also row ID has to be unique, which means that the design that our domain name has to be the row ID is good. The only problem with having the domain name as such as the row ID makes our data far apart. Data about the same domain but different subdomains, it makes it far apart. To fix that, what we have done is the we have changed the order of domain names. Okay, now you might argue here that this scheme may not work. Thank you, Lux. Thank you, Lux. Lux's point is that what about co.in, right? So for that, you will have to maybe keep an alias or something like that, and maybe remove, maybe have sort of remove this last TLD, okay, or something of that sort. All right, remove the TLD so that they become the same domain. Remove.com, for example, could also solve the problem if we delete this TLD. So apple.in and in apple.com will come together this way. All right. Now there were few questions. Sounds good to everyone? So this is what Google did. Basically, they keep the row key in the form of com.cnn.www. It took me considerable amount of time in my first database design in Cassandra to actually think in terms of these qualities of this database in order to solve your problem, in order to slice the data, in order to distribute the data. Exploiting all these properties to solve my problem was took me considerable amount of time. Again and again, I was thinking in terms of uh, multiple tables. Here, everything is being done in a single table. We are adding more and more columns into the column family, and we are also having this row ID. All right. Now let me just go through a few more questions. All right. Next question from Sanjay is there a strategy like creation of placeholder column families for future? Yes. So you generally, to future proof your tables, you generally create some of the column families for future. That's a good point. Now, another question that arises frequently is how do you decide that should we just have a fresh column family, or should we just add column into existing column family? The idea is that which data, the set of data which you require together most often, you fit it in a single column family. If you require some data not together, as in, for example, contents we will require generally together whenever we want to download, parse the data, do something, we will require this content together. But the anchor which we require in this case is only when we are computing the page rank. Therefore, it's okay to have them in different column families. But all the back reference links like cnnsi.com, mylook. They are part of the same column family. So it's easier for me to say, get me the data of all the column family for this row. And from that, I can figure out who all are referring to me, and then, and also how are they referring to me. So basically, you keep the data in the same column family which needs to be accessed together. All right. In the same manner, the time, because based on the timestamp, the contents of the file might change. Okay. All right. Sanjay's point was we to have domain column subdomains. Yes, that also could have been a good idea. Thank you, Sanjay. Now there's a question from Sanjay. How can we link column from one column family to another? You can't. Okay, you can just mention the column family name. So you can inside the cell value, you could mention that some sort of column family to the column family column name, sort of this, and then you can manually do go to that column and access it. Okay. All right, let's do a quick recap. Indexing is based on row key. Tables are sorted based on the row key, and row keys are unique. Each region of the table is sorted by row key space, which is start key and end key. Everything in HBase table is stored as byte array. Atomicity is guaranteed only at the row level. This is very important. Unlike the database where, unlike your typical relational database where you can have multi-row multi-row transactions, meaning create this record in this table, delete some records in another table, modify some third table, and everything you can do it in a single transaction. Single transaction as in everything gets done in a single shot and nobody observed any intermediary state. Either everything gets done or nothing gets done. That's a part of transaction. But that's not possible in case of HBase. But in case of HBase, you can have row level transaction. Row level transaction means that you could do multiple kind of changes in a single row and then commit it. Nobody will see what various intermediary states of this row. Nobody will see that, and therefore it is. And using this atomicity per row level, you could utilize, you could create kind of multi-state processes using the same mechanism. There are ways to create that. As well, you could create the workflow kind of transactions in using a single row transaction. Okay, single row atomicity could be utilized to emulate the multi database commits. All right. Same case is with respect to MongoDB and Cassandra. In MongoDB also, you you can only have a transaction guarantee on a single collection or single row. Okay, and that's true for almost all NoSQL databases. That you do not have multi table or multiple row transactions. Okay. Now column families have to be defined upfront at table creation time. Column qualifiers are dynamic and can be defined at any write time. Whenever you are writing the data, they are stored as byte array, so you can even put data in the column name. All data models, whenever you are getting the data is sorted by first row key, then column family name, then column qualifier, the the data, column qualifier data. I mean, I'm calling column qualifier data because it's a column name in which we store data as well. Just like in a matrix, you put the row number as well as column number. Similarly here, column family, column name, you exploit it for the data storage. And then timestamp. And for timestamp, it will be the descending order. For rest, it will be ascending. So, all right, there is a question, good question from Sanjay. So, in an application like sales, which has thousands of tables in RDBMS, how do we logically create tables in HBase as one big table with multiple column family can do most of the job? Yes. So, basically, if All the tables which share the row IDs, we will put them as columns, as separate column families. And then where there is a relationship between one data to another, the second data might become part of another column family, the way we have done it in our case. Okay, it's actually a fairly tricky to design an H-based database. Okay, and generally you have to let go of various kinds of referential constraints. All right, so let's have a look at HBase model. Hadoop 17. All right, so let's start the HBase shell. All right, here you can type list and it will give you the complete list of tables. Right now we have these many tables: 20 June, Ambari smoke test, customer underscore Anand, and so on. If you want to see what is there in 20 June, we can simply say okay, scan, and that table name. You can see that this has got only one row, and under one row these are the various columns: CF1 column 1, CF1 column 2, CF2 column 1. The value is val1, and these are the various different values for this particular columns. Okay, that's how the data is represented. Now let's try to create our own table. All right, also at any point of time you can see how many region servers are there. So it says that there are 3 region servers. Okay, you can also have a look at how many region servers are there from the Ambari. It says there are 3 out of 3 region servers which are alive at this point of time. Okay, so let's try to create my table with one column family. Okay, let's try to create my table with one column family. So what does it say? It says that the table already exists. Okay, let's try to delete my table, or let's try to okay, let's just try to first disable my table and then delete the table. In case of HBase, you have to first disable the table and delete the table. All right, so what does it say? It says drop the table. Done. This is done, and let's now try to create a table. Done, and let's have a look at whether the table is created or not. What was the table name? My table, right? Right now there would be nothing in it. There's nothing in it. Also, while asking for the table, you could also say things like in regular expression. We have said able and it has found out that. Or we could also say things like, all right. So we are using regular expression for finding our table. Okay. So here is our table. Now let's try to insert some data into my table. So what we are saying, put into my table, into this row ID, create a row if it doesn't exist, and then in this column, put 1, 2, 3, 4. Okay, let's try to do that. So if you say scan my table, all right, you can see it has created a timestamp and it has also added the value here. Okay, if we want to get the specific value, you can go to this and give you the specific value. If there are many columns, then it'll have that. Also, we can know about our table by saying describe. It shows you all the information about the table, such as the name of the table is MyC. It has got, there is one table and there is a column family MyCF and the various encoding, Bloom filter, replication scope, and compression, and so on. All the information about this table, right? And the block size is also, as we earlier discussed, that block size, we can define block size per table. So HBase, when creating the files, it defines its own block size. And when we were discussing HBase, we were telling you that for each file, we could also choose to define a separate block size. So HBase chooses to do that. Alright, that was about how do you create an HBase table. If you want to put more data into this, let me just put another data. So another row we are trying to create. And if we keep on creating this, it will still be the same. And we can say scan my table. Alright, alright. Also, you can see the running status. So somebody was asking, does it give us the detail about what's going on? So this is the interface where you can see the detail about HBase. So these are the basic statistics. How many region, number of regions every server is hosting. So Hadoop 4 is hosting 9 regions, Hadoop 2 is hosting 8, and Hadoop 3 is hosting 7. Okay. Now you can see that 92 blocks are locality, as in most of the blocks are on this machine itself. Okay, and so this is the all the information about all the tables which we know. So how many requests have come for metadata? There are these many requests. There are these many write requests which we have seen. These are the store metrics for every storage. What are the various number of stores, number of requests and everything. All right. So So it shows you all number of the tasks which we are running right now. All right. So yeah. Now question from Lux is, do we always need to know row ID to update? Yes. Okay. We cannot update a cell without knowing the row ID. Otherwise, you'll have to scan the table. How does the disable command impact the table? So since there would be some users who are trying to access the table already, so you let them read the data and then disable the reasons. So when you want to delete a table, all of its reason servers need to cut down all the access, and then it has to be deleted. So whenever we disable, it sends the information, a signal to all the reason servers that please stop reading this particular reason. And then it deletes. It doesn't delete just like that. That's there are some people who are trying to read or write. So it first disables a table and then deletes. Next question from, does it use MapReduce behind the scene? No. We have to do that. We have to do that. Okay, we'll go over that. Can we, from Vidya, the question is, can we add one more column like put my table? And yes, we can do that. Let's try to show you. Let me just copy your command and go over here. All right, so we have done it. So we can also put more columns, whatever you want. And let's just put something really strange. This is our column names. Did we put column somewhere? Yeah, we did not put the column family name here. So it has no complaint about what we have put as column name. Okay, you can see that it has no problem at all what we put as the column family name. And also we can keep on adding as many as column we want into the same row called row 1. It doesn't have any issues with that. All right. The question from Sanjay is, how do we bulk update rows in HBase? Okay, it's in continuation with the previous question. How do we bulk update rows in HBase table based on columns in column family? We do not know the, okay, so we will have to first find out the row IDs, and then you have to go and update those rows. Sounds very hefty, I mean, with respect to the workload that you have to do it iteratively, but yes. So HBase is not really a kind of cool SQL engine. Okay, there is no data modification language. DML is not there for HBase. It is just a data store. It doesn't qualify to be called a database. It's more like a data store. It doesn't give you that kind of SQL. Now Lloyd's question is, if we do not want someone to access a table for short time, can we disable it? Is there a way to re-enable it? I don't know actually. Okay, let me say. So status this alter, create, disable, and enable. Yeah, you can enable it. All right. You can see more command using by typing help. So Sanjay's question is there a database visual tool which can show us the table? Let me see if this guy is giving us any information. Is this giving us any information? Local table, debug dump. So it is basically this one is showing the basic information about the table. Beyond that, if I have to see view as JSON, there are nothing that is about the tasks. Yeah, this one, this is here. All right, the one where we came earlier at this place. If you go, you can see in detail, as in 20 June, Ambari smoke test, and everything. All right. So the table which we just created is here. Okay. So we have tried to compact it. Remember, we were talking about how could you compact the database in case we had deleted lots of records and we want to combine multiple regions into one, we could do the compact. And in case we are noticing the total number of requests are suddenly increasing in the table region, there is only one region right now. In case the table total number of requests are too high for one region, we can split the region. Okay, we can split the region, and that will solve a lot of problems. Okay, in case we want to say that instead of splitting automatically, split at some key called b, we could mention b here and then split the region. Okay. All right. So that answers your question, Sanjay. And Ravikant's question is, as per my understanding, we cannot do bulk update on multiple rows, right? So bulk update will be equivalent to adding more and more rows or updating. You cannot have a single transaction. Okay, no single transaction. Now user can also see hue to see table info. Is it? Yeah, I think so. Let me have a look. Where is no, it's not there, I think. No, it is not there. All right. So hue doesn't have interaction with that space. All right. Good. Very good set of question. All right. Yes. So that might be true actually. What Lloyd is saying that Cloudera Hue has it. Yeah. Actually, what they have done is they have not made the latest Hue installable, and I think somebody has to just create a new Hue because they're unnecessarily after making that open source, they are trying to still behave like a closed source people. Okay. So that needs to be broken. Yeah. So thank you. Like, let me have also have a look. How can we upgrade? Because I was trying to upgrade. Even we are actually working on a new cloud labs. Okay. And so we are working on something called Cloud X Lab. This one. Okay. So there we have the latest version of this one, and with that will be that's under experimentation still. So, but it doesn't make much of a difference, honestly. Although it says it has integration with that space, but still, it doesn't. Coming back to our discussion, let's. All right. So physically, the data is stored at this location. Let's have a look at it. That will give us a little bit more confidence about what's going on here. Okay. So the data is generally stored at this particular location in the file system. Apps at base data default. Okay. Now here you can see there is our at this is not the table. We have my table here. Under my table, as we are mentioning, there is after the table name, there is a reason ID. Reason ID is this one. A random ID, I mean a big ID is generated under this reason name. If you have multiple reasons, there will be multiple folders here. Under the reason ID, there will be the column family. Now notice the fact that we talked about. In the folder structure, the name of the my table has come as well as the column family name. Therefore, you have to make sure that these names of column family and name of the table are clear. Okay, let me try to exit. Has it updated? It's still in the semi cache. So I think if I flush, then it will go. Is it written now? Yeah, it has come now. Under now under the table name there is column family. Sorry, reason. So each table has got reasons. Each reason has got column families, all the column families, and then under each reason, under each column family is your file. This is the data file that has been created. Here you can see inside it, it has my data in the form called data block. Okay, so it's a single file of all the columns in a column family in a reason. So if you have 10 column families, there will be 10 such files for each reason. Okay, so a quick question. So if you have three reasons for a table and for a table for a table having four column families, how many files would there be? 12. That's correct. Thank you, Lloyd. Thank you, Sarvana. So looks like you are paying attention. Now here is a question from Sanjay. Can anyone change data directly in the HDFS without going through the put? So only the admin can do that. Only the admin can do that. If you see the group and the permissions, the group and the permission says that the user is HBase. So and the group is HDFS. So the users whose, and this one does not have the right permission for group or the others. Only the user itself can change that. So so only those who have permission to it can do that. And yes, theoretically you can change it. So we can actually select it and delete this. But then it will start giving errors. All right. Again, row updates are atomic. No matter how many row columns constitute the row label transaction. All right. All right. So when you are scanning the database, you will be using scanners. And the way you create the scanner is by this model. You create when you are doing programmatically, you will be using the scanner like this. Okay. So HBase scanners are more like the cursor in database table. They have to be closed after the use. Scanners returns row in the order. Okay. Scanners return rows in order. Users obtain the scanners by the following manner. Okay. You could say the table name dot get scanner, and then you specify the scan object. And the way the scan object is defined is at the row ID you want to start till the point you want to stop, and which column do you want to get. And so scan is more like where clause along with the column number names you want. So projection and part of the where clause is what scan has. So from which row to which row and which columns to which column you want to get from table. Okay. Sometimes you can optionally put a filter. This filter will be run against each and every value in the table. And once you are done with this, once you say, once you get the instance, and when you say rs.next, it gives you all the rows from that reason. Okay. And if you say next again, it will trip back to the reason server and get the data. All right. Now there is a question from Savna. If by mistake, if we deleted one file, okay, no. Will it be taken care? No, because HDFS itself has deleted the file. So when you delete a file in HDFS, then all the three blocks are gone. The question from Savna is that if we delete the file by mistake, will replication take care of it? No, because when you delete a file, it's gone. All the replications are gone. The way when you create a file, all the three replications are created. When you delete it, all the replications are gone. It's only in case of situation where where there's a hardware fault or a data node has gone down. Only in those cases the replications are taken care of. Now, Sanjay's question is, what is the limit on versions of a column change in column family? By default, you define three. Okay, by default, it's three. You could create as many past history as you want, but you will have to define it at the time of column family creation. So per for column family, you have to define that these many versions you want. Lloyd's question is, if I have a row with one column family and multiple column qualifier, can I just write one put for all the column qualifiers, or I have to do it separately? Okay, so you can, I think you can do it in a single qualifier as well. You can do it in a single. Okay, so here it is showing you that like this. All right. So there's a question from Sanjay. Scanners bring data into memory like cursor. Um, so scanners basically bring you those many records. When you say next or get the data, then it starts reading and gives you back. So I'm not sure if it is in the memory. So I'm not sure. I'll have to look into it. All right. Now there is another question from Sanjay. If we have multiple scanners active, can we inter-refer to columns in these scanners? Um, so if you have multiple scanners to a same table, and what do you mean by inter-refer? So in case of a scanner, you cannot jump back and forth. You can only go forward. All right. Okay. Like one column being joined to another column in other column family. You'll have to do it iteratively. You'll have to do it iteratively. It will be very difficult to join two columns like that. All right, because these are not as mature as the RDBMS is. Okay. In Java, this is the same thing what we did manually. You could do the same thing using Java code. Like here, we are creating a config object. Then we are creating an admin handle using this config object. And this admin handle will be using the table descriptor. All right. We'll be using the table descriptor for defining a table. And then we will, okay, then we will add this data to the same column family. Okay, so we define a column description like data, we add it to the, we add it to our same table. Okay, we add data as a column family in test, and once we are done it, we have defined a table called test with data as column family. We create this table. And once we have done that, we can list all the tables just like we listed. And in case our table contains the name which we are looking for, otherwise we give it an error that we could not create the table. And once we have done that, okay, we can add data into it. You define the byte array, and then you define a put, okay, and you create a put object. In the put object you all add all the values that you want to put, and then we can do table dot put, and it will put the data into the table, right? And then you can go ahead. So for whole library, there's a whole library for creating the data into HBase. Now you can see that it's not as beautiful as we had imagined, that we could just create, insert into database table and put all the values. It is very manual effort, right? Because most of the data manipulation language is not there in case of HBase or any other NoSQL as well. All right, we can create the mapper. All right, let's discuss it tomorrow. We have 3-4 more slides and that's it. All right, see you tomorrow. Have a great day ahead. Bye bye. All right, good night. Bye bye. Have a good day. Bye bye. See you tomorrow. Thank you, everyone. Thank you, Anandita. Thank you, Joshi. Thank you, Lloyd. Thank you, Mike. Thank you, Ravikant. Thank you, Richard. Thank you, Vidya. Bye bye. Have a good day.